All right, here's page 1, starting with number 4 of the Term 2 final. And I wanted to take a chance to just get you started on the things I know we didn't get to for everyone in class, or maybe we needed more time. The biggest thing, so the points for number 4, -4, 7 to -5. You're asked to get the slope. You're supposed to get the distance between the 2 points and then the midpoint. Slope, I think you know, is rise over run, or there's that old formula y2 minus y1 over x2 minus x1. All those approaches are addressed here. The first is which, you take the rise over the run, the slope, the up and down component over the left and right components. That'd be down 12, right 6, so that would be a slope of -2. So you could also take the coordinate points and do that x2 or y2 minus y1 over x2 minus x1. So the two y's that you see up above, -5 and 7, subtract them, and then do the 2 and -4 in the same order and subtract those, watching for subtracting negatives and things like that. Again, you get slope of -2 either way you look at it. Then there's the distance formula. It's a Pythagorean theorem. It's a squared plus b squared equals c squared, but what happens, c would be the length, the distance, the hypotenuse of a right triangle between a and b. Or you can just do this distance formula, which is pretty efficient, where the a squared is just subtracting the x's, which you see is -4 minus 2 squared. And then the b squared would be subtracting the y's, the 7 and the -5. And then you take a big square root at the end to find out not c squared or that hypotenuse squared, but just the hypotenuse. And that's what d represents here. D stands for distance, and it's always that formula, square root of the x's subtracted squared plus the y's subtracted squared, quantity squared. And that's what you see above under the blue there. And then if I actually do some minor calculation there, you get -6 for the first subtraction. We're going to square that. Then we get 12 for the second, square that. One's negative, one's positive, but it doesn't matter when you square something. It ends up being positive anyway, so we get 36 and 144. Add those together, we get 200. So it's the square root of 200. Well, we do need to simplify that, and tomorrow, next day, or whenever it is that I talk about this, or now it's in the past, you need to know how to simplify that a little bit, and that's to find a perfect square in 200, like 100 times 2, and that 100 is something we can take the square root of, so we can simplify that. We can do that square root, but we have to leave the 2 under the radical, so 10 radical 2 is the simplified version. Square root of 200 is correct, but 10 radical 2 is the actual value. Now, midpoint of AB, that's the average of the x's, comma the average of the y's. Averages are found by adding the quantities in a particular situation, dividing them by how many there are. We only have 2 of them. Add the x's, divide by 2, add the y's, divide by 2. If we do that, we get -1 and +1 for the x and y coordinates. That's the midpoint, -1, +1 between A and B. If you plot it in the picture to the left, you'll see it's perfectly in the middle. Now we're on to 5, 6, and 7. 5 is about angles. If those don't look like angles to you, just know that if you're shoving one of those expressions in the corner, it's an angle. And these 3 angles, we know, angles add to 360 if they're in a quadrilateral. Remember, that's n minus 2 times 100. Number of sides minus 2 times, did I say 100? 180. Number of sides minus 2 times 180. I'll write that formula at the end just to make sure you know. But in this case, they add to 360 for a quadrilateral. A little simplifying, the x is added to 9x, whole numbers to 108, and then we do a little algebra, subtracting 108 and dividing by 9, get 28 for x. The up above angles sum to 360 because n minus 2 times 180 in this case would be 4 minus 2 times 180, and we got 360 degrees would be the interior angle sum. 6 is about this mid-segment thing, which is the average of the bases. So we've got the DE base and the GF base. Mid-segment's always the average. Okay, it's a cool way to get the average between 2 values. And I've written that there. And 7, those angle bisectors that marked poorly, those meant, congruent angles. Those angle bisectors always divide a triangle, when it's within a triangle, into proportional parts. So we'll go with one particular proportion, solve and find x. So let's go back to numbers. Those are the 2 relationship. Average of the bases, that's a mid-segment. In an angle bisectors in a triangle make proportional parts. And then in number 5 up above, it was all about angles summed to n minus 2 times 180. and use that to, add all the angles to 360. So those are the relationships. Those are the big ideas. I could ask you a question on the test related to one of these, a little bit different, but using the same concept. Let's finish 6 here. So to average those, it would mean taking the two bases, negative or 0.5x plus 3, adding it to 2x minus 12, and dividing it by 2. Well, I did 1/2 off to the side, so note that. And that would equal the mid-segment 15.5. Well, that 1/2 out front of the expression, I can multiply both sides by 2, take care of that. And that will give us the following. 0.5x, the whole expression in the parentheses equal to 31, because that's what 2 times 15.5 is. Then the next is solving out to get 2.5x equals 40, and then dividing both sides by 2.5, we get x equals 16, you see there in the expression. So the idea is that the two bases divided by 2, I use times 1/2, equals the mid-segment, 15.5. Multiplied both sides by 2 to get rid of the 1/2, that's where the 31 comes from. And then combined x's, got 2.5x, minus 9 is the combining terms. Added 9 to both sides, divided by 2.5, and got x equals 16. All right, now to 7 again. Here's a proportion that works for this situation. X plus 6 over x, the two pieces of the top part of that triangle, and then the two corresponding pieces of the right or bottom portion of that triangle. Set them in ratio, cross multiply. Set those cross products equal, and then we'll distribute and solve from there. So don't forget to distribute the 8 to both terms. Then get the x's on one side. On the right, I've subtracted 8x from both sides. Then divide by 12, and we get x equals 4. That's the 3 big concepts of that section. Think of it: angle bisectors make proportional parts in triangles. Mid-segment is the average of the two bases. Angles of a polynomial add to n minus 2 times 180 degrees. And we are off. Next section, 8 through 11. First one is interior sum of a dodecagon. Well, n minus 2 times 180 gives us 1800 when n is 12. That's what dodeca means, 12. The next is two similar triangles, and I give you the pieces, PQ, QR, XY, and solve for one of those. So I labeled all of them, used W for the unknown YZ. And with similar triangles, one route to solving for missing sides is to set up a proportion of related parts, cross multiply, set them equal, and we divide. So set cross products equal and then divide by 5 in this case. It's not 3, by the way, it's 3.6. Sorry, I paused too early, so W is 3.6. So 10 is similar triangles, and what we have is a side of 3. The perimeter of ABC is 15 inches, and a side of the other NMO triangle. What we know is the ratio of two corresponding sides, which AB and NM are corresponding. The reason I know that is they are the first two letters of the similarity statement in number 10, and the first two letters in a similarity statement would be related similar sides. So AB is 3, NM is 5. So I make a ratio of those sides, 5/3. That's our scale factor, ratio of two known similar sides. And then, hey, the perimeter's in that same proportion or same ratio. So 5/3, that scale factor, is how we can go and take the littler triangle ABC, use the scale factor 5/3, multiply by a scale factor. Remember that in class we talked about you multiply by a scale factor to get a corresponding part, including perimeters. So I'm going to take 15, the perimeter of ABC, multiply by the scale factor, 5/3, and we will get our perimeter of the larger NMO. So if you see, here's the fraction work, 15 times 5/3, made it 15 over 1 times 5/3. You can also use a calculator. Cancel the 3 and the 15 for 5 and 1. You can see the markings there. 5 times 5 is 25 inches. Number 11 is about making what kind of triangles we're dealing with. So I'm going to go ahead and let that unfold, see the different setup. Remember, you do the longest side compared to the other two sides squared and added. So the longest side squared in each case. If it's greater than the other two, it's obtuse. Equal, it's right. Greater than obtuse. So we have two obtuse and a right. So that gives you the first page, at least 4 through 11. First chunk we did in class, so I hope you've got those tucked away or talked to a friend. And the next pieces are coming. Good luck. Do email with questions.